a definite integral here from root 2 to 2 of the secant squared of the inverse secant dx over x times the square root of x squared minus 1. So we need to let u equal something here. Why? Because I don't know how to integrate this function. So I need to let u equal something, and I guess a lot of times we might look to the denominator first, but notice if we set u equal to the denominator here, well, the denominator is composed of x and the square root of x squared minus 1. I mean, taking the derivative of that thousands of times, infinite times, will not yield trig functions, the secant squared. So that's no good. But if we know our derivatives of our inverse trig functions, in this case the inverse secant of x, we know that the derivative of the inverse secant of x is 1 over the absolute value of x times the square root of x squared minus 1. So I'm going to let u equal the inverse secant of x. And then that implies that du, when I differentiate both sides, that du equals 1 over x times the square root of x squared minus 1 dx. And the reason I left out the absolute value signs is because that's if x is negative. Well, x in this case is between root 2 and 2, and neither those endpoints nor the values in between of x are negative. They're all positive, so I don't need that absolute value sign on there. That's why we can leave it off. So we can go and make our substitution. I am going to change my limits of integration to u limits, from x units to u limits. So I have the secant squared. The arcsecant of u is now, arcsecant of x is now u. Dx over x times the square root of x squared minus 1 is du. So that really is going to make that, if we know our derivative, is going to make that substitution easy, taking that integral easy. So now I want to change my limits from x limits to u limits. So if x equals root 2, doing the lower one first, then that implies that u equals the inverse secant of root 2, and that implies that u is going to equal pi over 4. Now you can use the inverse secant graph, you can use the your calculator. In your calculator you might need to take the inverse cosine of 1 over root 2 to get this answer, because you might not have the inverse secant function on it. Mine doesn't. Or you could use your unit circle. I'm going to leave it at that. It's pi over 4. I use little triangles to think about it, just to get my values. But anyway, if x, oops, I need to erase those implies. X does not imply root 2, and x does not imply 2. Sorry about that. I think I said it right. If x equals 2, then that implies that u equals the inverse secant of 2, which implies that u equals pi over 3. And so u is going to run from pi over 4 to pi over 3. And now the function whose derivative is the secant squared of u is the tangent of u. And that's between pi over 4 and pi over 3. So that's going to equal the tangent evaluated at pi over 3 minus the tangent evaluated at pi over 4, which the tangent of pi over 3 is root 3 minus the tangent of pi over 4 is 1, and I don't think you can really get any more compact than that without getting a decimal approximation.